This video is about economic lot size and order quantity. It's section 6.3 in the text. And so basically the situation is when companies have to manufacture a bunch of stuff per year. The question is, should you make it all at once? Because then setup costs would be low. But everybody doesn't want everything at once. And so then you have to store it. And so that costs money too, storage space. So the question is, what is the most efficient way to do this that will cost the least amount? Should we make a batch of stuff? And so the word lot and batch will be interchanged, meaning the same thing. Should we make a batch of product one time a year and have to store all of that? Should we make it on demand so that we don't have to store anything? Or should we make it, 6 times a year and we have to store a little bit? What is the most economical way to do this? On the other hand, companies who order stuff, there's cost to ordering stuff. And so then if they order too much and they don't need it all at once, then they have to store it. And so they have to debate what is the most economical way to order. Should we order it 5 times a year and have to store a little bit? Should we order it 1 time a year and have to store a lot of it? Or should we have to order it on demand, but then it costs each time we order? So this is what they have to decide. So calculus and the first derivative test that we have used a lot of on this chapter helps develop these equations. So we won't be taking derivatives. We're just going to be plugging in numbers, but you got to know what each variable stands for. So basically, there's some blanks right here, and I'm going to fill those in for you. Economic lot size, it's the lot or batch size that results in the minimum, is what goes here, minimum production and storage costs for the year. This is what we're going to be trying to find out. So we're looking for the how many we should produce in a batch. Then economic order quantity is the flip side of the same situation. It's the amount of an item, or the number, the amount or number to order that will minimize the reordering and storage cost for the year. So that's basically the same situation, just on each side. One is the manufacturer side, and they're concerned with how much to produce. The other is the purchaser side, and they're concerned with how much to order. So there's a lot of similarities here. So on the manufacturer side, Q stands for the number of units in each batch. Also, you could say lot. And Q is a variable. There are several constants in this formula we're going to look at. K is the cost of storing 1 unit for 1 year. F is the fixed cost to set up production or manufacture. G is the cost to manufacture. A single unit of the product. And M is the total number of units produced annually. All right, so together there's the manufacturing cost plus the storing the completed product cost. So here is, they used calculus to come up with these formulas, and so the total cost, T of Q, FM over Q, this guy represents the setup cost. This is the manufacturing cost. The cost to manufacture times the number you need to produce. This is the manufacturing cost. Manufacturing cost. And then this right here is the storing cost. So all this together is what we want to try to minimize. Okay, so in the textbook, they do a good job of describing how they used the first derivative and tested it, and they came up with this. When Q, the number of units in each batch, equals to the square root of 2fm over k, the cost will be minimized. And so that is what they came up with using the first derivative test. So similarly, on the person who's got to order it, the purchaser side, the number of units to order each time, order goes here. There are several constants in this formula as well. K is the cost of storing 1 unit for 1 year. That's the exact same thing as on the other side. F is the fixed cost to place an order. There's a cost to this. And M is the total number of units that are needed annually that you want to have, that you want to order. So the reordering, so there are reordering costs each time you place an order, and then you storing cost if you have more than you can use at the time. So this is what this is. This is the F, how much it costs to place an order times the number of items you need per year. This is the ordering cost right here, and then this is the storing cost if you got to store it. So this is the formula. Q is equal to the square root of 2fm over k. It's the same variable. This is where they used calculus and the first derivative test that we've been using a lot of to come up with this formula. So this particular section is not that hard. We just need to recognize which variables are what and put them in our calculator correctly, and that's basically our job in this section. So we want to just take note of this. This is an important note. Q, the number of units in each batch, this was developed based on specific assumptions, and if the conditions change, a different conclusion can be reached. So you just have to be aware of that. This was kind of like done in a very clean environment where there's not a lot of things changing. So in real life, that could vary. All right, but let's just get used to this. Lot size. A paint company has a steady annual demand of 24,500 cans of automobile primer. The comptroller for the company says that it costs $2 to store 1 can of paint for 1 year and $500 to set up the plant for production of the primer. Find the number of cans of primer that should be produced in each batch, as well as the number of batches each year in order to minimize the total production cost. So they need this many. They produce this many each year. And so what does this variable, so this is about production, so we're on this side of it. And so what we need to do is recognize what they gave us. A paint company has a steady annual demand for this. So this is how much they have to produce annually, and that would be what M is equal to. That's our M. And then it says that it costs $2 to store 1 can of paint for a year. $2, this is what K is equal to, because K is the cost of storing for 1 year. And it costs $500 to set up the plant for production. Well, that is the fixed setup cost, that is F. And then what they said, find what? The number of cans of primer that should be produced in each batch. They want us to find Q. All right, well, all we have to do is use this formula. Q is equal to the square root of 2 times F times M over K, and we know what those numbers are. This is the square root of 2 times 500 times M, 24,500, divided by K, which is 2. And so you can put this in your calculator and you will find that 3,500 is the number of cans of primer that should be produced in each batch. That's how many they should make each time they produce a batch. Okay, then they ask us this. As well as the number of batches per year. How many batches per year will they have to do? How many batches per year? Well, the batches per year is equal to the total amount they have to produce, which is called M, divided by how many they're going to make in each batch. So M over Q is how we figure that out. So if we take 24,500 and divide it by 3,500, we get 7. So they're going to be making 7 batches per year. So that's our first example, and that's lot size. Now let's look on the flip side of order quantity. It's very similar. They say, let me just make my, sorry for the interruption of the paper. Okay. Okay. For the order quantity, a large pharmacy has an annual need for 480 units of certain antibiotic. This is how much they need to order. This would be called M. It costs $3 to store 1 unit for 1 year. This would be what K is. And this time we're on this side of the chart. The fixed cost for placing an order, clerical time, mailing, and so on, it is $31. This is how much it costs to place an order. So that we would recognize as F. Find the number of units to order each time. So every time we place an order, how many should we order? And then how many times a year should we order it? So first let's find this. Find the number of units to order each time. That is Q. So we still use the same formula. Q is equal to the square root of 2FM over K. So Q is equal to the square root of 2 times F, which is $31, times M, which is 480. This is all under the square root, divided by K, which is 3. All right. We put that in our calculator and we figure out that it's about 99.5 is what I got. So I just rounded that to 100. And then I said, okay, that's how many we should order in each time we place an order. So how many orders would that end up being? Well, if we need a total of 480, we divide that by 100. So this is still M divided by Q. And that tells us we need 4.8 times a year. You could use that literally, and that would be like 2.5 times each month. Or you could just say 5 times a year. And so that would also do 5 times a year, or if you wanted to be very specific, 4.8 times a year. Okay, here are 2 more quick examples. 14, lot size. A manufacturer has a steady annual demand of this many cases of sugar. This is how many they need. It costs this much to store it. K is our storage cost. 1 case for 1 year. And $31 in setup cost. This is our fixed cost to produce it. And $16 to produce each case. So there's this extra variable when we're on the production side. And this is G, how much it costs to produce each case. Find the number of cases per batch that should be produced. So that's Q. Part A is finding Q, which is equal to the square root of 2FM over K. So that's the square root of 2 times F times M over K. So that would be F, I lost my F, $31, times M, 13,950, divided by storage cost K, 9. And when I did this, I got 310. That is how much we should produce each time they make a batch. How many batches are they going to have to make, or how many lots? Well, the total number that they need divided by the number they produce each time. So that's 13,950 divided by 310, which gives us 45. 45 times they're going to have to do that. All right, last example. On the flip side, the order quantity, okay? A bookstore has an annual demand for 100,000 copies of a best-selling book. This is how much they need to order. That is M. It costs this much to store it. That is our K, 50 cents to store it. 1 copy for 1 year. And it costs $60 to place an ordering. So the ordering cost is F in this case. find the optimum number of copies per order. So how many should we order each time we order? And then that will determine how many orders we have to make. So part A is to find Q, which is still the square root of 2 FM over K. So this is equal to the square root of 2 times F, which is 60, times M, which is 100,000, divided by 50 cents. And when you put that in your calculator, you get 4898. And I rounded this to 4,900. And when you do that, then part B, when you find how many times a year should they be ordered, that is the total number they need divided by the number they're going to order per order. They're going to order about 4,900. Then I got about 2.4. So, 20.4. So sorry, this is my dog causing trouble. She's shaking the camera. Rosie, stop it. And so then you have to decide, you could do 20.4 times a year, but I might say either go with 20 or 21. If you order 20, you won't quite get 100,000 copies, and we need that many. So I went with 21 times a year in order to get the total number of copies. So this is the exact number, 24. If you were asked to round to a whole number, then choose the one that would give you the amount that you need. All right, so I'm going to do a separate video on elasticity.